Hi, this is Brett Haggard from htxt Africa. I'm here with Lungelo from Newcastle High School, yet another South African out here at Intel ISEF. Lungelo's invented a way to take pine cones and turn them into briquettes for alternative energy. Very good idea considering the fact that pine cones litter South Africa. We have a bunch of pine trees there. A lot of people harvest them and use them to put them in their fires, but they don't burn particularly well as a fuel like that, right? So you figured out a way to make them burn even better and last longer, correct?
Yep. Okay. So actually, pine cones actually are very flammable. Now, I use the pine cones to convert that flammability into a very viable alternative energy source that can be used for coal powered stations. Because anthrasite coal is the coal that is abundantly used in Africa, the States as well. And I can use that to create an energy source that can be used as an alternative to substitute anthracite coal, because anthracite coal is a fossil fuel that will be eventually depleted. Yeah, so that's what I'm basically doing with the pine cones, is converting them into a briquette. I'm basically making man-made coal, synthetically produced coal from pine cones.
So we're not really talking about the kind of pine kernels that people would. Well, it's everyday pine kernels, but people aren't going to use them for briquettes for braais, right?
Yeah.
We're talking about solving Eskom's problem of the coal, right?
Yeah. So then, like for example, Eskom, what actually motivated me to do this project is that in South Africa, our biggest energy source is coal, and we're depending on coal so much that one day we'll have to be importing coal to our country, which will cost us very, very, very large amounts of money. So now this way is a cheaper method of obtaining energy, because pine cones have absolutely no value. I mean, they're causing litter for us, and I'm taking that litter and producing something that can be useful for our future. It's more like protecting our future by providing. It's more looking at in a future perspective, because if you're gonna use something that's gonna be depleted now, think about later. Yeah.
Absolutely. So the big question is, apart from the fact that it's going to avoid constant mining of coal and the depletion of the coal resources, how does it stack up from a cost efficiency perspective? Is it comparable? So your process of using pine cones to create briquettes as an alternative to coal, is it price comparative or cost comparative to the process of mining coal right now?
Okay, so as you would see over here, the price of making my synthetic coal is very, very cheap. I mean, first of all, anthracite coal has a value, like how diamonds have value. Anthracite coal has value as well. That's one of the main reasons that make anthracite coal very costly. The maintenance for coal mines is very, very costly, and that should be absolutely cut off like immediately. I personally think. And then the labor cost. I mean, the machinery that it requires for anthracite to be dug. I'm saying let's not dig the coal. Let's make it, basically. Yeah.
All right, cool. From an efficiency of burning perspective, does it burn the same amount of time as coal?
So then, the synthetic coal, it burns super well. Anthracite coal takes a very, very long time to ignite, and this coal ignites super easily. As you would see over here, this is how the coal burns. It's magnificent. The flame is just it gives me a lot of excitement in my blood. And then the duration is slightly different, and the peak temperatures are also slightly different. But then that's not the main essence of the whole idea of producing synthetic coal, because it burns at 1,029 degrees Celsius. That's 10 times the boiling point of water. If it can boil water 10 times more, I mean, that's what we want. 10 times more efficiency. That's basically what we need.
So the difference between that and coal in terms of, coal's obviously got a much higher temperature, right?
But it's a very, very small difference between anthracite and synthetic coal. It's almost not of essence that's there's a difference in, yeah.
And in terms of the duration, how different is the duration?
Okay, anthracite coal burns from about 6 to 7 hours, and it requires so much energy. I mean, 3 million years to form coal, and you can do that in just 15 minutes. And that's actually what is more important about this, is that I'm using less energy to form the synthetic coal, and anthracite coal, 3 million years. it's like a faster way of producing an alternative energy source, and it's also a dependable way of making energy, because we can't keep relying on wind energy and solar energy, because those resources are not always available for us, because sometimes it's winter and we have no sun. I mean, the sun is there, but not as much as it would be in the summer. Yeah.
Okay, so and what is the duration of your synthetic coal's burn time?
It's about I made a lot of tests. So the latest one that I was confirming was about 5 hours and 27 minutes.
So it's not a massive difference, right?
Yeah, absolutely not, because the duration is determined by the combustion things that like time, oxygen supply. Yeah, so then that kind of makes the difference between the combustion duration.
Okay. Tell me this: how do you do this? How are you taking the pine cones and creating your synthetic coal out of it?
So I take the pine cones, collect them, and partially combust them in a controlled oxygen supply area, and then it'll form like a carbon source from almost like charcoal, but not exactly charcoal. It's carbon 12, which is much lighter than carbon 13 from anthrasite coal, and then I take the coal and pulverize it into a very fine powder. It undergoes very processes of sieving, and in that fine powder makes it easier for me to alter the chemical structure and the composition of the coal. So from that process, I take a pentacosane, which is like a catalyst that makes me require less energy to reach the reaction I need to reach, which is also aiding into me using less energy than anthracite coal, because I can't say, hey, there's something I'm using and it uses a large amount of energy. So then once I do that, I mix it with the carbon and the pentacosane. It's a chemical catalyst, which has 25 carbon atoms and 52 hydrogen atoms. And then I pressure it only using 10 tons and at 1003 degrees Celsius, which is here I'm just trying to illustrate that less energy can be used to form as an alternative energy source that can be used in power stations, unlike using 3 million years of energy. Yeah, that's basically how I do it. And then after the compression and heating stage, that's what you get.
Okay, very cool. And then last question: does Eskom know about your fantastic innovation, and have they expressed interest in using it?
Not as yet, but I'm pretty sure they have to look at it when coal runs out, because I mean, I'm not sure why they're not even thinking about that. They keep using like solar panels. I mean, there's a project going on in South Africa about solar panels. I mean, let's try to use something that we can rely on. I mean, like if we planted more pine cones are like absolutely no use at the moment. So let's put that into use is what I encourage.
Okay, fantastic. Well, very cool, very good idea. I take it your inspiration was it really, about the fact that it's a uniquely South African thing, how bad the power situation is in South Africa and how costly power is in South Africa, and this is going to obviously bring that down. So very, very well done, and best of luck for the awards. The awards are this evening, so I really, really hope you get some recognition for a very, very novel and very clever idea. Thanks, Tapel.
Thank you very much.